in the over-the-counter and in the daily practice inside hospitals. And that is, of course, part of the activities that under the new strategy of combating antimicrobial resistance in Saudi Arabia.
Yeah. Thank you, Dr. Hussam. So, Dr. Yazid?
Yes, I have a question for Dr. Hussam. I've met microbiologists and people who worked on developing antibiotics. And they said that the notion of trying to combat abuse of antibiotics is a failed war. It's a lost war. So we need not bother with that because you have a global community with easy access to flights all around the world. So if you control an antibiotic substance in a country, then you'll have people coming up from different countries. So don't you think the focus should be developing alternative methods of microbial defense and targeting, for example, variants genes and targeting and manipulating genes?
I think nowadays, absolutely, that is truly urgent. But again, I will take it to the fox hunting culture. That is absolutely true. However, our medical colleagues are very comfortable using antibiotics. They were trained on using antibiotics. Not until a few weeks back when the Ministry of Defense or DIAC in the state used, for example, the phage therapy to try and treat patients with pan-resistant Acinetobacter baumannii. But however, that is only a single case, and it was quite experimental. The reality is, I think we still have to use antibiotics for several reasons. They have proven over the years that they are amazing. The antibiotics, I mean, despite the collateral damage that they can cause, antibiotics are amazing, and they have proved that they should be relied on. But I'm with you. I think in parallel to that, we should also look at different strategies to combat antimicrobial resistance or the microbes, apart from antimicrobial as antibiotics. So the options are available out there. But usually, when you see the amazing science happening in research laboratories, the translation of that amazing science, the CRISPR example, for example, is amazing. However, when do you think you will see the CRISPR diagnostics in the clinical laboratories or in the clinical practice? I'm not quite sure. Hopefully we will be able to change that culture, but it's a reality. Thank you.
Thank you. Thank you for both of the speakers. And I think now we're going to finish off the morning session. We're going to start the afternoon session as we schedule. 1 o'clock. Okay. Before, we're going to do the certificate just only for the speakers. Dr. Yazid. نلتقي ان شاء الله هنا ان شاء الله الساعه 1 ان شاء الله بحول الله.
for the لأن في واحد زميل من العين اسمه الهاملي فتلخبط علي حياك الله دكتورة فاطمة. طبعا دكتورة فاطمة she is خريجة طبعا يونيفرسيتي يونايتد ستيت في الميكروبيولوجي. هي الآن طبعا هي ساينس at King Faisal Specialist Hospital and Research Center, and she is assistant professor in College of Medicine Al Faisal University. She has a lot of actual membership in different society, and we welcome Dr. Fatma for the lecture.
Thank you, Dr. Al-Harbi, and thank you everyone for being here. Hope you enjoy your lunch, and now we are ready to start. The topic is going to be interesting. It's going to be different. As the theme of today, actually, I like it. It was kind of a flavor from different fields. Today, we are going to talk about the next generation sequencing that can be applied in any field. So whatever you are doing right now, it will be applicable to your field. So today, I will be talking about the emerging opportunities for next generation sequencing in infectious disease outbreaks. So to start off usually with the first slide, we are in the globalization right now where an outbreak everywhere is a risk everywhere. And this is the truth. As we are speaking right now, there are outbreaks like Ebola in Africa. There is cholera. I know Dr. Salim is in charge right now in Yemen. There is the avian flu in Asia. So there are outbreaks over there, and all of us, we have to be vigilant and ready to combat all these infectious diseases as we can get affected easily. So when it comes to infectious diseases, globally infectious diseases represent the greatest cause of death. It might even outnumber the non-communicable diseases. New infectious diseases are emerging every year, as we all know, and sometimes re-emerging infectious diseases are there, and sometimes they come back vicious and more deadly. Zika as an example, if you all heard about it. More rapid spread of IDs are facilitated by modern demographic, environmental, technological, and societal conditions. Dr. Walid Salim covered this area very well, where why infectious diseases spread widely and with the borders, with the travel, and with the new lifestyle, deforestation, all of these actually reflected on the spread of the infectious diseases. This is a geographical map from the WHO about the outbreaks data. So it basically, the black dots, it represents the origin of the outbreaks. If we look at Africa, most of the infectious diseases originated from Africa, followed by the Eastern Mediterranean, then the South Asia, and the Western Pacific. There are a few cases from Europe. There are more cases in in America, especially the Central and the South America. This map actually depicts a very important point that we all should know is most of the infectious diseases happened in the poor and developing countries. And that's why the burden of diseases worldwide from those regions. So if we look again, the same data, actually it's in a box plot. It shows you the median time between the outbreak start and the WHO confirmation. So how many days it takes for the outbreak discovery? If you look at this data, it's taken from like 13 years, from I think 1996 to 2006, I believe. So if you look at the outbreak discovery, it takes up to 23 days to get the outbreak discovered. It takes up to 32 days to get the public communicated and they know there is a problem there. It takes maybe 35 days for the laboratory confirmation, and it takes over 45 to 46 days for the WHO to write a report and notify everyone about the outbreak. This is a very lengthy process in these days. Who can wait all this time to have an outbreak detected and communicated to the public and get everyone alert? So the situation, just imagine this situation, the 46 days, maybe it's in developed country. What about if this outbreak happened in developing countries? I think the situation will be worse. The public health infrastructure, if it's lacking or weak, that might make the situation worse. If the infection prevention and control measures are not well practiced, And this happened actually here with MERS coronavirus. Most of the infections were in hospitals. And finally, and this is the worst, whereas political pressure is present. So again, when it comes to infectious disease, everyone is affected. So back to our story that happened in Saudi Arabia, it's the MERS coronavirus. And I'm sure all of you have heard the story. Just to unfold it now briefly, just to put everyone on the same page and the importance of using advanced technology to not repeat the same mistake. If we look at Corona story, basically, in June 2012, a patient was admitted to the hospital with severe respiratory symptoms that quickly progressed to acute pneumonia and renal failure. The patient died after 11 days. However, during the patient was hospitalized, there are so many regular tests that were done in the hospitals. They took the blood and sputum, they ran immunofluorescent, they did PCR. So basically, because they are working with unknown, they tried different set of primers for the PCR. First, they thought it's a swine flu, so they tried the primers. They started to use different primers just to identify this microbe, and it failed. Actually, it was all negative. They inoculated the samples into cell culture, and they found there is a virus there, but they couldn't identify the virus itself. So the patient, as I said, died, but the question was still alive. Dr. Zaki actually was smart enough to look at different viral group. He looked at the pan-coronavirus primers. He actually thought that virus, it might be from the corona family, and it was a positive results. But again, the family huge, there are so many strains there. So what he did, he thought maybe it's a SARS. So he used SARS primers, but it was negative. So again, that means you are dealing with a novel human coronavirus. So basically what he did, he was like trying everything randomly, then he tried to narrow it down using a PCR as the best technique in molecular technology, and this is what he got. This took over 2 months. And actually he worked really hard, and 2 months was the best he could have done. And that's why I mentioned this story as 2 months again. It's a very long time. You cannot wait whenever you have an outbreak, and it can be transmitted easily. So all the above promotes the need for more rapid outbreak detection technique. And that will lead us to today's talk when we talk about next generation sequencing. So next generation sequencing, basically, it's a high throughput sequencing technology. It's a higher speed, less labor, and lower cost, and the cost actually it's getting cheaper every year. There are different platforms developed. If you all remember the pyrosequencing, the 454 Life Technology or Life Sciences, followed by Illumina. Ion Torrent now are really common, and it's almost in every institute as they are doing very well. And more, as I said, every technology here has different detection principles. We will tap on this while we are going through the presentation. So if we look at the different technologies here or different platforms, so it depends on the genome size, depends on your question, it depends on again, the cost or the budget that you have, you want to buy this technology or not, the accuracy, because everyone has an error rate. So again, if you are gonna do it with a patient, it has to be really with the lowest error rate. While you are doing it for research, you might ignore that part or go with other alternatives. So again, the giga bases per run, so you can see the log here, and here the read length. How many you can sequence as a short reads, then you can align and make the contigs. If you look at those different platforms, when we talk about microbes, usually MySeq from Illumina and the pyrosequencing are the best so far. Unfortunately, those two are not, still it's not in the market. Actually, they pulled them out or they discontinued that machine. So now our bet is the MySeq, which is from Illumina. HiSeq always is good if you are looking for larger genome. Usually it will go with the bacteria very well, and the human genome, usually you will go with HiSeq. The reads is very important. Personally, when I work with next generation sequencing, if I want to do the assembly myself, I will go with the long read. So it will be easy to assemble them. However, if you have a bioinformatician, they would like to have the small reads, like they would go with the small ones here, less than 100, like Illumina, and they can use softwares just to do the alignment and come up with results. So again, different platforms will answer different questions, just depends on your question. So these are the application for next generation sequencing in general. If you look, you can do whole genome sequencing, you can do whole exome sequencing, you can do PCR amplification. I remember Dr. Samira Al-Juhani, she mentioned today so many technologies that use for sepsis. She didn't mention the next generation sequencing, and when I talked to her, she said, well, it's in a process, we are thinking to use it. And instead of waiting to culture a microbe, you can go ahead from the blood sample immediately and sequence it and get the results. Some results, it takes up to 3 to 6 hours. For the advanced or fancy machines, some will take few days. So it depends again on your budget. It depends if you are using it in clinical settings or just a research. For a clinical setting, you will go with the faster and more accurate sequencers. Again, with the transcriptomics, so many questions can be answered with transcriptomics. You can know the gene profile and the gene expression of your samples, especially if you are working with cancer patients. So all these are applications can be utilized using the next generation sequencing. When it comes to next generation sequencing and infectious disease, again, other application that can be used. So it can be used for detection, it can be used for characterization, host pathogen interaction, therapeutic or vaccine development. So all these can be used with the same technology. Today we are going to focus on the detection. So the next generation sequencing has been developed since 2006 after Sanger sequencing. So since 2006, you can see most developed countries have already worked on the next generation sequencing. Maybe it's not just to identify the new microbe, but it could be just to investigate more. Okay, they know this sample is already positive, but they want to do, they wanted to do a sequence for the whole microbe or others. So this kind of the publication, it's from Nature Review Microbiology, where they mentioned this technology has been tested since 2006. What we are planning to do right now, or after this, lots of research been done and the technology is validated, and now even most kits are FDA approved, that can be used in a clinical setting. So what we are proposing or thinking why we don't try it is to go with a metagenomics approach. When we say metagenomics approach, is basically when we are talking about a sample from patient. Let me say, like this is the samples from patient. It has so many microbes, you don't know, it's unknown. You are working now with the unknown. This patient is coming with the severe symptoms. I take this sample, regardless from where you took this sample. There are viral, there are bacterial, fungal organisms here. You don't know exactly. You take everything here and you do nucleic acid extraction, where you extract everything present in this sample. Even when I say nucleic acid extraction, you will do DNA and RNA, just in case you don't miss the RNA viruses. And you just sequence everything there, and you will get the results. That's what we mean by metagenomics. You sequence everything. You are not going for target sequence. And with the metagenomics, you can get rid of the human cells if you are targeting only microbes. So basically, you will filter out the human genome or human cells, and you just focus on the infectious agents over there. And why I mention this, because it's very important. Anyone who worked with the NGS, they know the mass amount of data generated. It's overwhelming to see the data coming out of your samples, and it will be really hard to do the sequencing and the alignment and generating the contigs. So from the beginning, if you get rid of the human cells and just focus on the microbial cells. Again, this is an example, maybe I already showed you. You have a sample from patient, any type of samples. You do nucleic acid, not DNA, nucleic acid extraction, If it's RNA, you make the cDNA, you pull them back. Sometimes you need to do whole genome amplification if the sample's minute. So you combine them back, you fragment everything, you sequence everything, and you get the sequence. Then I will show you, again, with that sequence, you can ask so many questions, but in our case, we are working with unknown. I want to know exactly what this patient has. So you go with the analysis pipeline, you get the reads, you start to align the reads and make it longer reads. You have two options now. If you know exactly what you are looking for, I know I'm looking for a viral genome, I would do mapping to known genome. This is very easy. However, the hardest part when you are working with the unknowns and you do the de novo assembly, where you assemble everything, then you start to read the context by blasts, and you will get a list of microbes that match in the database. Let's say 90% or 99% matched in the database. You have a few didn't match. So now you focus on those new. If you think that's a novel infection, it might be clear from the beginning what the match was, and you can start the treatment immediately. Both, they need to be confirmed. Next generation sequencing as microarray technologies, it's a broad technology, give you a sense, but again, you have to reconfirm it by PCR or real-time PCR. So what is the advantages of using metagenomics approach? It requires little to no prior knowledge of the organism. Again, he's coming with the symptoms, I don't know, let me sequence everything, so I would like to know. Relative speed in comparison to the traditional methods. If you compare it to the old molecular, it's not old, but the gold standard in the molecular techniques, again, it has more advantage. And detect non-culturable organisms. Again, as I mentioned with Dr. Samira, you don't have to culture the organism and wait a couple of days or a couple of weeks to get the results. Immediately, you can get the results within a few hours. I always compare or see the metagenomics, the de novo assembly basically as a puzzle. You have pieces of information, then you put them together and you get the final picture. You can identify the microbe or the microbes with that patient. Here is actually the technology being used already in a clinical setting. This is a paper basically where they took a serum sample from a returning traveler. He had acute febrile, and they used the NGS, resulting in detection of human herpesvirus 7, and it took only 48 days. This is actually like 3-4 years ago, and now I'm sure it takes less because the PacBio, I think now you can get the results within 3 hours. If you look at even the hands-on, the pink bars shows the hands-on time. It's not that much, but imagine now with the automated systems, even there is no time, hands-on time, because immediately you will get the serum or the sputum, you put it in the machine, then you will get the results immediately. The important thing is you have to have a bioinformatician, a good one. That's the team needs to work on any NGS, basically. Is it frozen? I think they didn't buy it, was it? Do you want to try it? Okay. I think, okay, thank you. So this is again another paper. What they did is they tried different platforms, because what happened, and most of you have seen that, you see the marketeers, they will come and they said, okay, we have the best technology in market, and they will try to convince you with the things that this machine capable of doing. What you should do always is just to identify your questions, what your question is, and is it right for you or not. What they have done here, they tried different platforms. They have tried Roche, the pyrosequencing, they tried ion current and MySeq. And they wanted to see how low they can detect with the viral DNA. So basically they got blood samples and they spiked it with known microbe and just try different technology just to see if it's accurate. It will identify the microbe that I spiked my samples with or not. As you can see, every platform has something different than the other. It might be a strength. If it's important for you, you can go with it. Like the Roche was capable of detecting very low amount of the virus. Ion torrent and MySeq were the best for detecting the viral genome at concentration of about 10,000. The MySeq were good for bacterial as well because it could identify it very easily and classify the bacillus. So everything has its advantage and disadvantage. It's like you have to come up with your own list and your needs. Like, what do you need? And based on it, you go with the platform that you think it's going to be applicable in your laboratories. This is another paper actually we did in 2011 in the States. It's basically we were trying just to validate the technology. It was the pyrosequencing technology. We were looking at the viral communities in wastewater samples using the pyrosequencing. It was like when the technology started back in 2010. So we tried this technology just as a proof of concept. What we did, we got wastewater samples. Basically, it was very quick experiments. We filtered them just to get the viral community only, and we did transmission electron microscopy just to visualize there is a virus there. And then we did the viral nucleic acid extraction. We did the pyrosequencing and bioinformatics. It was very easy because you filtered out everything, and when it comes to the viral genome, it's a short genome, so it was easy to be done in our laboratories. And then we verified the results using the PCR. All of this was done in 4 days. And this is, again, back in 2011. Now I'm sure it's going to be very fast. So now it sounds fascinating, it sounds like good to be true, but again, there are so many challenges when it comes to the next generation sequencing technology. First of all, the sample prep and extraction techniques affect the quality of sequence. If you don't start right, you are not going to get good sequence. In some cases, there is a lack of appropriate reference genome for comparison, and we saw this with our own experiments when we sequence the viral communities in a wastewater samples. Almost 99 were unknown, like you couldn't even find them in the database. So finding the reference genome is sometimes harder. Bioinformatics, especially here in Saudi Arabia, it's rarely to find a good bioinformatician that you can team up with, because with this you need a bioinformatician. There are so many softwares that you can utilize, but again, you need someone on board just to help you to analyze the results. And again, it still needs verification, still need you order your primers and verify your results. Conclusion, next generation sequencing has the potential to accelerate the identification of unknown pathogens. The introduction of benchtop now sequencing has made it possible to be used during outbreaks. Some NGS instruments are FDA approved. That's why we suggest to have it in your lab, because it's a benchtop. It's something like practical. We have to facilitate it in every lab, or at least in every institution. You have to have a core facility, or in the clinics, you have to have it in the main lab as one option whenever you are facing challenging situation. You can always run your sample utilizing this technology. Recommendation and future direction. So benchtop sequencer for routine detection in clinical setting. This is kind of a common practice in advanced country or developed countries. We want it to have it here. As we are all prone to infections, we always see sick people. We don't know what they have exactly. We just discharge them, but it's always good to sequence. Whatever results we have to have our own database and sequence the samples that we have. Sequencing core facility, action plan, trained staff. This is a must, especially in a national lab, wherever you want to face an outbreak. This is a must, and this is like kind of